The large frame. The large frame represents individuals with naturally greater stature, longer limbs, broader shoulders, and larger bone structure, found in approximately 15 to 20% of populations outside of populations where tall stature is prevalent. This build is characterized by the capacity for substantial total muscle mass, greater absolute strength potential, and the defining feature of reduced surface area to volume ratio that provides exceptional heat retention in cold climates. The genetic mechanisms involve variants promoting height and bone density, including favorable FGFR3 gene variants affecting skeletal growth, GH1, and IGF-1, variants promoting greater linear growth, and genes affecting bone mineral density, creating more robust skeletal structure. These factors reduce bodies capable of supporting substantial muscle mass, generating maximum absolute force, and maintaining core temperature efficiently in cold environments. From an evolutionary perspective, larger body size provided decisive advantages in cold climates and contexts where size and strength were critical. This pattern appears most clearly in populations from Northern Europe, where cold adaptation favored larger, more compact body builds that retained heat efficiently. Following Bergmann's rule, the biological principle that within species, populations in colder climates tend toward larger body size. The reduced surface area to volume ratio of larger bodies minimizes heat loss, reducing energy expenditure for thermoregulation in harsh winters. For populations in Ice Age Europe or Arctic regions, larger body size wasn't just beneficial, but necessary for survival. The thermal advantage meant lower risk of hypothermia, reduced caloric requirements for maintaining body temperature, and the ability to tolerate extreme cold that would be fatal for smaller individuals. The substantial frame also supported greater total muscle mass, providing the absolute strength needed for hunting large, dangerous game like mammoths, constructing substantial shelters, and transporting heavy loads. The longer limbs and larger skeletal structure create mechanical advantages for force generation. Longer lever arms allow more torque production, broader shoulders provide attachment points for larger muscles, and denser bones withstand greater forces without injury. However, the advantages of size come with substantial costs. Larger bodies require significantly more total calories to maintain, more food for basic metabolism, more protein for muscle maintenance, more resources for tissue repair and immune function. The reduced surface area to volume ratio that enables heat retention becomes a severe liability in hot climates, where heat dissipation is critical, potentially causing dangerous overheating during sustained activity. Larger bodies are less efficient for endurance activities, requiring more oxygen and energy to move over long distances. The greater absolute strength comes at the cost of reduced strength-to-weight ratio. During food scarcity, larger body size dramatically increases caloric demands, making survival more challenging. Greater skeletal mass and size create more joint stress and mechanical wear over a lifetime. Still, in environments where size provided clear survival benefits, cold climates requiring heat retention, hunting contexts where strength and reach were decisive, territorial defense where physical dominance mattered, these costs were worthwhile investments that enabled survival and reproductive success. Every body composition pattern reflects the interaction between genetic inheritance and the specific environmental pressures faced by ancestral populations. Understanding your body composition means recognizing not a fixed limitation or aesthetic category, but the result of genetic variants that provided specific advantages to your ancestors in their environments. The body you inhabit today carries the metabolic, structural, and physiological characteristics that enabled your ancestral line to survive, adapt, and ultimately succeed across thousands of generations of environmental pressure. These traits persist not as defects or ideals, but as the diverse adaptive legacy of human evolution across vastly different ecological contexts. Don't just watch the world. Like this video and subscribe to understand it. And if there's anything else you would like to learn about, drop it in the comments section.